start recording. Okay, guys? Alright, here we go. So, if you guys recall from the video, when we look at something, if it says f of 1 like that, that's old school. We've done that for a long time. This is the y coordinate you get when you plug in x equals 1. Okay? So I'm going to write this, the y coordinate you get when x equals 1. The limit as x approaches 1 of f of x is the notation that we use whether or not we can actually plug in 1. So sometimes you can plug in 1 and you really do get a y coordinate. And in that case, f of 1 and the limit as x approaches 1 happen to be the same answer. But sometimes when we look at the limit of something, we are describing a y coordinate that should be there, but it is not. A great example of that is a hole on the graph. Do holes on the graph actually show up? Are they real points on the graph? No, they're a point that's skipped. Do they have y coordinates? Yeah, they do. Right? So a limit is saying where the y coordinate should be, like logically speaking, where should that y coordinate show up? But it may not actually be defined there, okay? So here I'm going to say the limit is what the y coordinate should be. And you guys are going to do a whole lot more with limits when you get into calculus. So this is kind of just like a little introduction. Because all of you guys are taking calculus. Right? All of us are.
Yeah.
You take pre-calculus, so you can take calculus next. I thought you were SpongeBob. I didn't know we had a puppy in the room. All right. So if we look at number 1, I'm going to start at part D because that's the part that I'm comfortable with. So if you plug in 3, what y coordinate do you actually get? Not yet. 1. You actually get a y coordinate of 1. So when 3 is plugged into the function, the y coordinate actually equals 1. I can tell because that's where it's filled in. Alright. So now, if we're going to find the left-hand limit and the right-hand limit, the left-hand limit means you're going to start at the left arrow, the furthest left on the function, and you're going to follow the line, and you're going to see what y coordinate is on the line. So what y coordinate do we see? 2. So 2 would have made more sense. It's not a random point off in space. 2 would have made more sense. That's actually on the line itself. That's a little bit more logical. If we want the right-hand limit, we're going to start at the right arrow, and we're going to follow the graph until we get to an x value of 3, and our y coordinate here is negative 2. So if half of the people are saying y is supposed to be 2, and half of the people are saying y is supposed to be negative 2, then does everybody agree? No. So we're going to say it doesn't exist. There is not a y coordinate that was supposed to be there. So the limit is what y coordinate should be there that makes more sense. A random point in space doesn't really make sense. A y coordinate that's actually on the line, that makes a lot more sense.
But the signs behind the 3 didn't think was like those answers.
That's left. Did you watch the video?
Okay. Yep. I did.
Yep. Okay.
Yep.
So the negative after means left side, right side. Okay. All right. Number 2. We are looking at the limit as x approaches negative 2. So first I'm going to jump down here and I'm going to say the y coordinate where the x coordinate is negative 2. So if I look at the graph, x value of negative 2, what's the y value right there? 2, positive 2. Okay, now I'm going to go ahead and find my limits. So from the left side, I'm going to start with the left arrow, and I'm going to trace the graph until my finger gets to negative 2. The x coordinate of negative 2. What y coordinate is my finger at? 2. If I do the right hand limit, so I'm coming from the right side, here's my right arrow. I follow my right arrow down, 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 and then I fall off into infinity. And then I jump up and keep coming at it from the right. You guys see that? So I'm tracing it, tracing it, tracing it, tracing it. My finger goes down, and then I jump up, and I keep tracing it from the right. So where is my finger at? 2. So eventually, when my finger got to an x coordinate of negative 2, the y value there was still positive 2. So half the people say the y value is supposed to be 2. The other half of the people say the y value is supposed to be 2. So what's the y value supposed to be? 2. So this is one of those situations where what the y coordinate actually is and what the y coordinate looks like it should be happen to be the same number. Okay. All right. We're going to add another one to the same problem. So we're going to say the limit as x approaches 0 from the left, the limit as x approaches 0 from the right, and then the limit as x approaches 0. And I also want to know what happens when I plug in 0. Okay. So if you look at the graph, what happens when you actually plug in 0? You get a y coordinate of 0. That's where it starts. Okay, so if we actually plug in 0, we get a y coordinate of 0. If we follow the graph on the left side, I'm going to start at the left here with my finger, and I'm going to trace, 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 and I'm going to keep tracing until my finger gets to an x value of 0. And what is the y value at my finger? 0. Now if I start from the right side, and my finger is following it, following it, following it, following it, following it, and my finger is going to go down forever, right? My finger is going to trace it, my finger is going to get closer and closer to 0, but it's never actually going to hit 0. So if my finger goes down forever, what number is down forever? Negative infinity. So 0 from the right side is negative infinity. So if half the people are saying the y is supposed to be 0 and the other half the people are saying it's supposed to be negative infinity, then what do we say? It doesn't exist. Those two groups of people are not agreeing with each other.
So it skips 0, but the only reason we jump is because we weren't trying to get 0,
We were trying to get to negative 2 at first. Yeah. All right. Let's look at number 3. Melissa, you need to come up here and grab a copy.
Yeah, I'm up here.
All right. So what happens if you actually plug in x equals 1? What y coordinate do you get if you actually plug it in? You actually get 2, because that's where it starts. All right, so 2. Now, if we start at the left arrow, and we trace it, trace it, trace it, trace it, until we get to an x value of 1, what value is my finger at? 3. If we start on the right side, and we trace it, trace it, trace it, trace it, trace it, until we get to an x value of 1, we have 2. DNA. Half the people said 3, half the people said 2. We don't agree. It does not exist. Yeah. It's because we were tracing it as it got close to 0, and so we just traced. We jumped up when we were tracing and we were trying to get to negative 2. But when we're tracing it, trying to get to 0, we're just going to keep going down this line. We're going to get, because that's how asymptotes work, right? We're going to get closer and closer to that line. We're going to trace it down forever. We're never going to actually get there. All right, let's look at number 4. What happens on number 4 if you plug in 0 for the function? Negative 3. You actually get that point, negative 3. All right. All right, and then if you trace it from the left, we're going to trace, 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 negative 3. We trace it from the right, trace, 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 negative 3. And we are all in agreement, it's negative 3. So this isn't, yeah, it's unanimous. This is another case where the y value that is there is the same as the y value that makes sense to be there. Okay? All right, turn the page. I want you guys to do 5 and 6. 5 and 6. 5 and 6. Melissa, did you take your notes last night?
Oh my goodness, right? Number 6.
All right, so for number 5. For number 5, are we ready? The actual evaluation is 3. If we trace it from the left, we start at the arrow, we go down, we go up, and the y coordinate should be 3. If we follow it from the right, it should be negative 2. Does not exist. Not yet. Alright. Looking at number 6. Looking at number 6. What is the actual y value at x equals 2? 3. The actual y value is 3. If we trace it from the left, we're going to go this way, we're going to go up, 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 we're going to follow the asymptote up for a long time, and then I'm going to hop over to the other side of the asymptote and follow the asymptote back down, follow it. The y coordinate should be there as 1. If we follow it from the right side, the y coordinate should be there as a 1. So the limit is 1. So the actual y coordinate that is there is a 3, but the y coordinate that would make sense to be there is 1. It should have been a 1. All right, go ahead and flip the page. I want you to do A through J. A through J. So you're skipping K, skipping the bottom one, A through J. All right, so coming at 0 from the left side. So if I start on the left side, and I'm getting closer and closer to 0 on the curve, what y coordinate am I at? 0. If I come at 0 from the right side, I'm coming this way, I hop up here, and I come down, and I'm at 0. Y value 0. So if half the people say it's 0 and the other half say it's 0, then we conclude it's 0. Okay? If we are coming at 1 from the left side, then I'm coming from here. I go my y value is 1. If I come at 1 from the right side, it's 0. So from the left side it's 1, from the right side it's 0. Does not exist. Alright. Alright, now when we look at 2, if you come at 2 from the left side, we're going to start at the very left side of the graph. We're going to trace it, 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 jump, trace it, trace it, trace it, now I'm at 2. 0. If I try to come at 2 from the right side, can I trace any part of the graph? No, because there's nothing there. So it does not exist. There is no right side of the graph. I can't trace it if it's not there. So if the left side is 0 and the right side doesn't exist, our conclusion is it doesn't exist. Okay? And then this one is saying, what y coordinate do you actually have at 0? Where is it dark? Dark at 1. Woo! Okay. How do we feel about that stuff?
Not bad.
So the big thing we're looking at today is if you look at the curve, what y value makes sense. If you look at the curve, what y value makes sense to be on the curve? Does that sound reasonable? Okay, so I'm going to write that on my paper. Limits if you look at the curve. Do you guys know what I mean by curve?
Yeah.
Okay. So if you look at the curve or you look at the graph that you made, what y value makes sense? That's what a limit is.